Hello students, I am Sayon from the Department of Mechanical Engineering. Today I am going to discuss about one of the operations that we can perform on lathe, that is the taper turning. Okay. In my previous videos about the operations on lathe, I have already discussed about two operations, that is the straight turning and the facing. Okay. I'm going to summarize all my lectures. That is the in case of lathe operations, we can perform a number of operations like turning, facing, taper turning, grooving, okay, chamfering. That is why it is not called a machine. This is called machine tool. Okay. In case of our straight turning operations, we can reduce the uh, diameter of the job. Okay, and in case of facing, we can reduce the length of our job. But in case of our this taper turning, what we can do, this is our point of our discussion. Okay, so I'm going to my slides to discuss about these operations. So what do we mean by taper turning? In ordinary straight turning, the cutting tool moves along a line parallel to the axis of the work, that I have already told. Okay, causing the finished job to be the same diameter throughout. That means throughout the work there we can see the same diameter. Okay, but when cutting a taper, the tool moves at an angle to the axis of the work, producing a taper. Okay, therefore, to turn a taper, the work must either be mounted on a lathe, so the axis upon which it turns it at an angle to the axis of the lathe, or cause the cutting tool to move an angle to the axis of the lathe. Okay, I'm discussing this through my next slide, that is taper turning picture. Yes, through the definitions I have already told. In case of normal turning, like this portion we can see, this is our actual dia, and this is our reduced dia. That means after the machining. Okay, we can see this is the bigger one and this is the less dia than this. That means we have done some machining operation, that is the turning, and in the entire section we can see the same diameter. Okay, and the next part, that means this part, this is called taper. Okay, and we have done the operation that is called taper turning here. That means I'm talking about this portion. In this portion we can see the diameter is removed uniformly. Okay, that means gradually reduction of diameter we can see through this part. Okay, and this is the actual fundamental thing of a taper turning. Okay, through this taper turning process also we can reduce the diameter, but the reduction of diameter will be in uniformly way, in the uniform way. Okay, or the gradual reduction. So here we are going to show you what are the procedures of the taper turning and how to calculate the taper angle, basically through this video lecture. Okay, so this is a standard picture of a taper turning. This is a process to do this cut the taper. Okay, I'm going into detail in my next slides. So here is the taper turning methods. The methods are using the compound slide, by using the form tools, offsetting the tailstock, and using the taper turning attachments. Okay, in our workshops, so basically we prefer the first one, that is the using the compound slide, and we can also use the form tools also. Okay, so next I'm going to show you one video. The video is downloaded from the another website, so you can also view to that website also. Okay, and I have using this video for the better understanding. So I am playing this video. Sorry, 1 minute here. So first one, that is the form tool method. Okay, so we are watching, this is our entire lathe, this is the headstock, and this is the tailstock, this is the carriage. Okay, and it is the one of the simplest method to produce a short type of tapers. Okay, so we can see in the chuck, one workpiece is held and it is rotated through the chuck. This is our carriage, this is our tool, that means form tool. Okay, and this is held in the tool post. Here is the process we are doing the taper, and this process is called taper turning. Yes, here it is also written. And one other information that is written here, I'm showing you again, that the taper angle, 1 minute, taper angle should be less than the tool cutting edge angle. This is an important point, please note it down. Okay, again I'm playing. Next one is the tailstock setover method. Okay, so here the website was written, you can also prefer to that website. Okay, this is the process. Actually, this is the headstock and this is the tailstock, and in this way the workpiece is held. We can see the centers are not same. Okay, this is the axis of rotation, upper one, and this is the tailstock set over axis. This is our taper turning tool, which is held into our tool post. Okay, and this is the process to do the taper turning operation. Okay, here the chips are coming out. I have already took a video lecture about the mechanism of the chips. You can also prefer to that. All of my other videos are available in my website, and the links are available in the description side. So here the calculation is written. I'm going to show you the calculation. Next method is the compound rest method. This is common used methods that we use in our workshops. Okay, so this is our workshop, this is our tool, this is our compound rest. Okay, compound slide, sorry. So we are swilling this. Okay, yes, the compound rest is swilled to the required angle. Here there is a indicator, and we can set the angle. Okay, just like a protector. Here the angles are written. Okay, and this is a common technique that we use in our workshop. I'm telling again. Next, taper turning attachment method. Uh, Here, this is also a very popular method. Here, in this part, the attachment is there. Okay, so in this picture, we can see this is the headstock, this is the tailstock, and the entire job is held in the tailstock. Okay, so and this portion is our attachment, taper turning attachment. Okay, we can see how the taper turning operation is going on through this guide. Okay, or this attachment. Actually, we are adjusting this screw. Okay, and we are also adjusting the degrees to make the taper. But at first, making any taper, we have to determine how much angle we want to produce. Okay, so I'm going to my next slides. That is the processes, that is the taper turning attachment that we have also are also seen in this our video lecture. So I'm not going into detail. Please read all the lines and pause my video to every slide to note it down. Okay, this is very important. Next, I'm going to my next slide. I'm not wasting time to reading all these lines. This is the compound rate. I have already told many times. This is a common technique that we do in our workshops. You can see again and again the videos. Next, offsetting the tailstock. Here we can see this is the headstock, this is the tailstock, and the axes are different. Okay, and this is also a common technique to make the taper. Okay, and no separate attachment is required for this offsetting of tailstock. Next, here is the important thing, that is the how to calculate the taper angle. Okay, so I'm going to my previous slide again. So we can see here is the angle. Okay, so before cutting this taper, we have to calculate the taper angle. So our objective is to calculate. That means I'm going to show you how to calculate this. So this is our initial dia D1 and this is our final dia, that is the D2. Here it is written. Okay, and taper angle is alpha. Okay, if we extend these two lines, then this will meet here, and this is also alpha, and this angle is 90, and this length, total taper length, this will be we can consider as L. Okay, you may take any another the thing like the XYZ, anything. Okay, I'm taking this length as X. Okay, if we see this portion, this is alpha. In these portions also we can see another angle, that will be alpha, like this. That means I'm talking about this. Okay, so uh, this distance will be X. Okay, so now we can see D1 minus this portion and this portion, that means X plus X, that means 2X. This is equal to the distance, that will be D2. That means I'm talking about this portion. Okay, that means this will be D2. Okay, I'm telling again, I'm assuming the distance of AB, or the value of AB is X. Okay, if we take another taper, that means if we consider the this portion, that's here it also be angle, that is the alpha, and we are assuming this length also is X, because these lengths are equal to each other. Okay, so the entire length is D1. This is our initial dia and this is our final dia. So from the D1, if we deduct these two lengths, that means this portion and this portion, then we can get this intermediate section. That means I am talking about this portion, which is equal to the final dia, which is the D2. Okay, that means D1 minus 2X is equal to D2. Here from this equation we can get a value of X that will be D1 minus D2 by 2. Okay, and here X, the value of X is equal to AB according to this picture. AB. Okay, now we are calculating the value of alpha, so we are taking the the value of tan alpha. Then tan alpha will be, if we consider this triangle, then the value of tan alpha will be AB by BC. AB by BC. Okay, so here we can put the value of AB. This will be our D1 minus D2 by 2, and after that divided by BC, and the value of BC means this portion, and this is equal to the L that we have taken, L. That means the value of tan alpha will be d1 minus d2 by 2l tan alpha. Okay, this is the actual formula. Okay, this is the actual formula for the taper angle. Here is it is also written tan alpha is equal to d1 minus d2 by 2l. Okay, another things are written here, that d1 here capital D small d is written, but according to our picture this will be our this is our d1 and small dia will be d2. Okay, so this is the entire calculation for the taper angle. So I think all the portions I have covered for the taper turning. If you like this video, please like and subscribe my channel so you can get the notification of my upcoming videos. Okay, thank you for watching.